All right, so the next two examples that we're going to be talking about is lifting a chain. So how much work does it take to lift a chain? Okay, so if they tell you that the chain weighs, shall I wait?
Please.
Oop, not 50 pounds. The chain weighs 5 pounds per foot. And I have a chain that is 20 feet long chain. I want to know how much work it would take to lift the whole chain to the full extended height. Okay. So if I had a chain that's coiled up here, let's say this is chain, all right, I'm going to grab one end of it and I'm going to lift it up. Okay, that's what we're talking about here. I want to know how much work. So remember, work is 4 times distance. So if you notice, the weight is given, right? So if I did a little strip here like this, that little strip is represented by x comma y, and this will be my dy. So by looking at this picture and the weight, it would be the change in force would equal 5 pounds, right, per foot, times the length of it, because I gotta cancel out the feet, and this would be just dy. This is dy feet. Does that make sense? So part of a chain weighing at 5 pounds per foot, if I multiply by the length of the foot, I could find my force. Okay, the reason why I use units like this is so that when I cancel the out, because dy is in feet, right, I get force, which is 5 pounds dy. So then I can move my units over and say it's 5 dy will be my force. And did you see it's a part of a force, not a full force, because it's just that one little section right there. Okay, so we got this. So now I'm going to plug into this. So W is equal to integral of force times distance, right? Well, I am trying to pull up the full length of y. I don't know what that length is, right? So we're just going to make that y. So distance equals y. So W equals integral of 5 dy times y would be my equation. Okay? And I'm taking that height, right? This height, and I'm going to pull it up. So what are my bounds? How high do I want to go? 20. So it'll be 0 to 20, because I want to put it to the full extent of the length of the chain, so 0 to 20. So when I rewrite this, I get integral of 5 on the outside, y dy from 0 to 20, and that's an easy integration. Yes? Okay? Any questions with the lifting of the chain? So it's kind of similar to pumping water, except you're dealing with the weight of the water, and you have to multiply by the volume to get the force. In this case, because it's just the length of the chain, and they said the weight of the chain is by the length itself, so you take the force, to find the force, you multiply the weight by the length. So this would be the weight times the length will give you the force. This will be the force. Okay. So any question with lifting the chain? And I'll go through some of the problems with you guys. Okay. Any questions with this one? So this is lifting the chain. How much work it takes to lift the chain.
So
go ahead.
Would be 100 pound-feet?
Hmm?
Would the answer be 100 pound-feet?
Oh, I don't know. I didn't finish. I'm sorry. You want me to finish?
It should be 1,000.
5, this would, the integral of y dy is y squared over 2 from 0 to 20, right?
20 squared is 400.
So this will be 5, and then this will be 400 divided by 2 minus 0, right, which is 200. 200 times 5 will be 1,000 pound feet.
I actually made it 40 instead of 400.
Oh. Okay, any question with this one? And then the last one is a expanding air. So you have a piston. So I'm going to draw you a little piston. Okay. Work done by expanding gas. I'm just going to give you a simple equation to use. So here's a cylinder. I'm going to call that a piston because there's a mechanism. And there is gas is over here. Here's gas. Okay.
It's a good piston.
You like my piston?
Very well.
Okay. Pressure, which stands for pressure of gas. The units is given is in terms of pound-feet squared. Okay. We're going to use volume of gas, which is in feet cubed, right? Volume is feet cubed. Does all those units make sense?
Yeah.
Okay. If I multiply these two together, what do my units end up being? Pound feet. There's my work, right? So work technically is pressure times volume. Pound feet, right? Pound for feet squared times feet cubed is pound feet. And that's my work. Okay? So part of the work, so if I were to move a little bit, right, it's the integral of P dV. Okay, let's put it that way. So then if I integrate this, I get work equals pressure and part of the volume, because volume is going to what we're trying to change. And pressure is inversely proportional to the volume. Okay? Inversely proportional to the volume. That's what P equals. So everybody understand this is what it means? So as the volume increases, what happens to my pressure? Decreases, right? Because it's inversely proportional to. Makes sense? So if I rewrite this, work of a expanding gas would be then kV times dV. K over V times. This is the equation you want to use to find the work done by the expanding gas. So this is a very simple equation, okay? So in a given cylinder, right, if I wanted to find the part, if I drew it right here, what would be the volume of that cylinder? What is the volume of this cylinder right here? V equals what? And this being, let's say that's my dx. Huh? This is a cylinder, right? How do you find the volume of a cylinder? Pi r squared h, right? Pi r squared h, where the radius, right? If I had this would be the radius from here to here. That's my radius, right? So this will be y squared dx, right? That being the radius. Okay. But we're going to use this. So I'm going to give you some examples. So I'm going to pick a particular problem to work on that one. Okay. Any questions? So to add to your list of equations that I gave you yesterday, remember I gave you this. I gave you Hooke's law. This was for what? What was Hooke's law for? You guys remember? Spring, right? It's a compression or stretching a spring, so this is spring problem, all right? Newton's law is the propulsion of the satellite, which is given by this. And then emptying a tank. How much work does it take to empty a tank of fluid, right? Which is given by this. So then to that, I would add lifting of chain, right? So if I said lifting a chain, that will be, what did I say? Force times distance, where force is equal to weight times the length. Okay? Weight times the length. And I spelled weight wrong. So you're still using force times distance. Okay? And then the last one was the expanding gas, right? We had expanding gas. So work done by expanding gases, work is integral of K over V dV. What will be the integral of this? K over V dV. Huh? Integrating. It'd be ln of V. ln of V. This will be an ln. K ln of V. Yeah, will be your integral. Any questions so far? You have questions on the homework? Okay. So I'll just give you the rest of the homework, okay? So I gave you yesterday this, right? 9, 11, 13, 15, 18, 19, 21, and 23, and that only covered the first three. So we had the pumping one, and then we got so I gotta give you, what did I give you? 23, all the way to 23, right? And then, do I want to give another pumping gas? You know what? Let's do... Alright, so let me give you number 29 for lifting a chain. And... 31. Lifting a chain. And I'm trying to remember which questions that I had on the test. I'm trying to think of. Let's see. 43 is gas problem. I should give you one more gas, huh? Let me do 44. Okay. Okay, so I'm adding 4 more. Is that fine? Huh? Is that good? 4 more? Okay. Say it again. Oh, yeah. Yeah, so I don't know how much work problem is on the AP exam. I haven't seen too many of it. And a lot of times it's probably like just pressing a force on an object and how much work does it, because I had one where I have a, I think it was this one. No, maybe it wasn't. Anyway, okay, so what was your question? 13. So let's look at number 13. You had that one? You're on number 13? Okay. So, here we go. So, I'm gonna just end my recording. Bye.